All right, so this lesson's on problem-solving strategies. Just where you know, this is kind of like an overall math kind of lesson. And what I mean by that is it's not any particular little skill. It's a skill that will work on a lot of word problems throughout the year, no matter what kind of word problem it is. And not just word problems, but other kind of problems as well. So it's just a good helper overall. All right, so here we go. Problem-solving strategies. Our very first one is, and you probably have heard of some of these, all right, is sometimes, depending on the problem, you want to look for a pattern. Everyone? I know it's kind of weird, right? Because it's not just a word, it's almost like a sentence, but it's still part of the vocabulary. So, your book says looking for a pattern. This is a problem-solving strategy in which you analyze the first few terms in a pattern and identify the rule that's used to go from one number to the next. Okay? So, you know, probably in elementary school, 2, 6, 10, blank. Okay, so that's kind of, you're finding the pattern and you're finding out what the next sequence is. All right? So, the next term in the sequence. So, that's just an example of looking for a pattern, probably when you've used a pattern before. All right, our next phrase is, I always learned it when I was younger as guess and check, but now they call it guess, check, and revise. Everyone?
Guess, check, and revise.
All right, so you want to guess, you know, if it's just some problem where you're just looking, you're plugging a number in, seeing if it works. If it doesn't, but why they put revise in there, you don't want to just keep plugging random numbers in there. You want to see what's happening, and so it strategically will plug certain numbers in. And then you revise, change it, and do it again. All right, so the book says this is a problem-solving strategy in which you make a reasonable guess, check it in the problem, and then use the results to improve your guess until you find the solution. All right, so I just put down long division. So when we do long division, that's what we do. We guess, check, and revise. All right, when it's really big numbers, all right, we'll take a look. We have some strategies to give us a good guess, but we're still guessing. And then we try it out. If it doesn't work, then we do that. All right, thank you everyone that have your notes out and pencils. All right, so here we go. The next term is, this is another strategy, make a table. Everyone?
Make a table.
And you got to remember, sometimes you'll use these strategies with others. You can use more than one in one particular problem. Here's what this is. It says it's a problem-solving strategy in which you use a table to organize your information in an understandable way. All right? So, just where you know, making a table. Now, not that a multiplication chart is like someone problem-solving and making a table, but a table is an example, or a multiplication chart is an example of an actual table. Okay, so sometimes if you take a look, right, multiplication charts not only are charts or tables, but there's patterns to it. Okay, so there's a lot of these that kind of are intertwined. All right, the next one, work backwards. Everyone?
Work backwards.
All right, so usually work backwards starts with like them asking you what the starting point is, and then it tells you the rest of the situation. And then so you start with the end, like the end result, and work backwards. And that's probably what this says. It says a problem-solving strategy in which you start with the end result and undo each step that led to the end. So undo it meaning like doing the opposite. That's what it means to undo. So you buy something for $2, you have $5 left. Well, then the question would be, well, what'd you start with? Right? You buy something for 2, so you lost it. So something minus 2, you end up with 5. Well, what do? You just go, instead of subtraction, you say 5 plus 2. You add the 2 back onto the 5, and you started with 7. Okay, so that's what it means by work backwards. And of course, these examples are very basic ones, but it gives you an idea. All right. All right, any questions on those? Okay, so here we go. Examples, go ahead and flip over to page 28. Page 28. And then go ahead and grab your paper. Like I said, you could either grab a new one or you could just grab the one that you were already working on here. All right, page 28. Okay. Hopefully everyone's ready to go. All right, so what we're going to do is we're going to try out number 5. All right, if you take a look, it just says number 5, use a strategy to solve each problem. So they're just asking you, just use whichever strategy you'd like that you feel goes with that particular problem. You know, there might be one particular strategy that will work better than others. All right, so this one says, number 5, it says, a ball bounces back 0.6 of its height on every bounce. If a ball is dropped from 200 feet, how high does it bounce on the 5th bounce? Round to the nearest 10th. Okay, now, here's the thing. I'm thinking right now that if I'm looking at that, I can actually draw a diagram. That's actually another problem solving strategy that's not in here. I could draw a diagram that might help. Okay, so it goes down, bless you. Okay, it goes down. And it says it bounces back 0.6 of its height, so a little more than half. And then what does a ball do, right? It drops again. And then it goes up a little more than half its height. Okay? It's 0.6 of its original height. Now there's a diagram, but if I'm taking a look at this, my end result is they want to know how high does it bounce on the 5th bounce. Well, that's kind of reasonable to actually do the math. But to keep track, here's what I'm going to do. All right? And this could be step 1 is pick a strategy. I'm going to go ahead with this because if it was asking me for the 100th bounce, I might want to find a pattern because I'm not going to calculate all the way to 100. Okay? But it says it's only a 5th bounce. I probably can calculate it and by using a table. So a chart, a table, here we go. This is bounce number 1. All right. So the drop happens at 200 feet. I'm going to even draw a diagram labeling what this is. So it's going at 200 feet. So here's the first bounce. It comes up to 0.6 of 200 feet. So if I want to label this could be drop. Just organizing my data in a table. Here's the drop. Or I should maybe not say drop, but maybe bounce is a better word. So off the first bounce, how high does it go? This is the height off the first bounce. So what I'm going to want to do, right, is off the second bounce, off the third bounce, off the 4th bounce, off the 5th, and this, of course, will be our answer. So I'm just organizing my work to get there. Okay, so listen carefully. This is the first time I'm going to talk to you guys about this. Okay? I'm going to let you on this, if there is big multiplication, okay, I'm going to let you use a calculator tonight. Now, I'm not saying you don't have to show any of your work. You're going to notice I'm building a table to show my work. But I do need to calculate all of these numbers. So the first bounce is 200. If I need to find out what 0.6 of that is, I'm going to multiply 200 with 0.6. Now that one's kind of easy, right? Because you have 1,200 and move the decimal over once. The height is going to go back up to 120 feet. Maybe I want to put feet here. Now, of course, it goes down and bounces back up to 0.6 of the 120, right? So now I take the 120, multiply it with 0.6. So I haven't even had to use a calculator yet. So 6 times 12 is 72 with the 2 zeros. But look, I've got moving the decimal over twice now. So 1, 2, it's 72. Might be a good idea to just make sure, remember you're tracking, it should be, this one should always be a little more than half of this, because 6/10 is a little more than half of 5/10, which is a half. Okay? 72, I'm going to rewrite it here. 72 times 6/10. And I don't even know if we need a calculator, to be honest with you, on this, right? 12, 40, that's 43. Decimal over 1. So 43 and 2/10 off the third bounce. Off the fourth bounce, 43.2 times 6/10. So 12, 18, 19, 24 plus 1 is 25. 1, 2, 1, 2, 25 and 92 hundredths. Now it does say round to the nearest tenth, right? Ladies and gentlemen, don't round until the end if you can help it. The more you round, the less accurate your answer is. So notice how I'm at the hundredths. I'm leaving it. I'm not rounding yet. I'm rounding it at the end. Okay, and then the last part, of course, and I guess, sorry guys, pick a strategy. I forgot. Step 2, right, is use the strategy. All right. And then, of course, step 3, I don't even know if this is really a step, but, of course, make sure you write your final answer here at the end whenever you find out what it is. So 25.92 times 6/10. That might be a calculator problem. So 25.92 times 6/10, and I end up with 15.552, or 15 and 552 thousandths. Okay, now I'm rounding to the nearest tenths. If you forget what the tenths is, I have a place value system right there. Tenths is just to the right of the decimal. Okay, probably most of you guys already know what that is. Here it is. Look at the hundredths. The 5 makes that 5 round up, and we end up with 15 and 6/10. Now, don't forget, I'll even put this as a step in here. Guys, yeah, if that ever happens where you can't see some of my calculation, please remind me. Okay, don't worry about it. Just kind of let me know. We have 15 and 6/10. I guess we could say step 4, if you want to call this a step. Don't forget your units. All right, probably should put it right here. Remember, it's a word problem. So reread the question. How high does it bounce on the fifth bounce? 15.6. Well, it does say all the units are in feet. 200 feet is where it starts. So it's referring to it in feet. So 15 and 6/10 feet. And there's our answer. All right. Questions about using a table. Again, remember in our definition, it's just, all of this we're still calculating. It's just sometimes if you calculate, you forget which calculation you're on. So using a table will help you find that. Okay. Any questions? Okay. I will let you try number 1, but actually looking at the time, I do want to go over problem number 4. I want to do one more with you where you can see some different strategies to use. So problem number 4 on page 28 says Tia used half of her allowance to buy a ticket to the class play. Then she spent 1.75, or I should say $1.75, right, for ice cream. Now she has $2.25 left. How much is her allowance? So it's the missing start, right? It's given us the end. We can work backwards on this one. This is one of those where we can work backwards. So she used half of her allowance on that. So you could say we're multiplying by 1/2. So she has her allowance. We can even put X if we wanted to make it algebraically. So half of her allowance, so X times 1/2. And then she turned around and spent $1.75. So minus $1.75. And she has $2.25 left. So here's what you can do. Working backwards is going this way. Remember, undoing it, doing the opposite. So that means I could take $2.25. Instead of subtracting $1.75 from it, I'm going to add it back on. So it's almost like we're going back in time, and she's now almost getting a refund for ice cream. That'd be a little disgusting, right? So I'm going to add the 175 back into her wallet. 10, 9, 10, 2, 3, 4. So she has $4. Now remember, it says she used half of her allowance to buy a ticket to the class play. So remember, it's not 1/2 of 4, right? We're not multiplying 4 by 1/2. You could say you're taking 4 and doing the opposite of multiplying by 1/2. You're going to divide by 1/2. So if you divide by 1/2, remember, it's been a little while maybe, but KFC, right? Keep, flip, change. Change a sign to multiplication, 2 over 1, or which is really 4 times 2. And ladies and gentlemen, our answer is 8. Or in this case, don't forget your last step, $8. And hopefully on a problem like this, take a look. Let's run it through here. Let's see, she started with $8. She spent half of it on her class play, right? What does that leave her with? $4 if she spent half of it. Then she took the $4, bought ice cream for $1.75. Is 4 minus 175, 225, what the story tells us? Yep. So that should know right off the bat by checking it in there. Plug it in there, see if you have the right answer. Okay, questions on that one? You can multiply by 0.5. Well, be careful. You'd have to divide by 0.5 to get your $8, not multiply. Because multiplying by 0.5 is the same as multiplying by 0.5 right up here would be wrong. That'd be still giving you, it would have given you $2, which would have been the wrong answer. Okay, so you're doing the opposite. Don't forget to do the opposite operation to undo it. Okay, really quickly, guys, sorry. Go ahead and take a look at problems numbers 20 and on. Those are all review problems, all right? So take a look. Number 20, obviously, there's some problems in there. Actually, you know what? I cut those out, so you don't have to worry about it. Fantastic. Ta-da. So you don't have to worry about it. All right, guys, go ahead and you can start packing up.